Welcome, everybody, to today's panel discussion. We are excited to bring you today's discussion, how open source technologies are accelerating robotic innovation. We've got an amazing lineup of panelists today, so please do post your questions in the chat. We'll see if we can get to all of them, and time permitting. If not, we'll follow up with you after today's live stream to answer your questions. A recording of this discussion will be emailed to you after today's live stream. It will also be available on O3D YouTube. There's a playlist there called Panel Discussions, and you can find it there after today's live stream. We also have a short survey for you after we wrap up today's panel discussion, and we'd love for you to fill it out. It's a quick survey to really help you shape the series and tell us what you'd like to hear about and what we can do better. And with that, I would love to introduce Rowe O'Brien, who will moderate today's panel. He is General Manager of Digital Media and Games at the Linux Foundation. Rowe, take it away.
Thank you so much, Nicole. I really appreciate it. Again, my name is Rowe O'Brien, and of course, I'm at the Linux Foundation. I'm also the Executive Director of the Open3D Foundation, so I get a chance to work with everybody in the community, as well as a lot of the people here that'll be in this panel. And to kind of get things started off, I'd like to introduce some of our esteemed panelists. So we'll start off with Matt Hansen, who is the Principal Solutions Architect at AWS Robotics. Matt, tell us a little bit about you.
Hi, thank you, Royal, and good morning. Yeah, my name is Matt Hansen. As Royal said, I'm a Principal Solutions Architect at AWS. I've been at AWS for a few years. My background is in hardware and software development, particularly robotics. And for the last few years, I've been working closely with companies that are developing simulations to simulate their robotics as part of their development flow. And currently I'm in the simulation technology organization within AWS.
Awesome. Thanks so much, Matt. And we're going to move over to Robin Rowe, who's the CTO of Rowe Robots. Robin?
Thank you, Royal, and thank you for having me here today. My background, my very first project actually many years ago was building the robotic television studios at NBC. I've been a Navy research scientist, a DARPA principal investigator for AI. Mostly I'm a creative technologist. I've done animation and visual effects work that you've seen in major motion pictures. And I'm really excited about what O3DE is doing and robotics. In robotics, I've worked on unmanned ground vehicles. I've worked on unmanned aerial vehicles. And I think today's session is really going to be fantastic.
Awesome. Awesome. Thank you so much. And we're going to move over to Lars Gleim, who's a senior research engineer over at Huawei. Lars?
So yeah, thank you very much. My name is Lars Gleim. I'm with Huawei Cloud in Germany, working on cloud native simulation technologies. And I have a background in computer science and business. Previously worked for several years on making manufacturing more efficient through the better use of data, as well as data integration. And a big part of that, of course, is robots and cyber physical systems. And so that is also what connects me to cloud native simulation. And within O3DE, I'm also the chair of the special interest group for simulation, focusing on all parts, physics, animation, and robotics. So I'm very happy to be here and looking forward to the discussion.
Very, very awesome to have you. And for the next, we'll have Mabel Zhang, who's a software engineer over at the Open Robotics team at Intrinsic. Mabel?
Yeah, thank you. My background, it kind of started in graphics, and then I wanted to do something real, so I went to do vision, and then I wanted to do something even more real, so I shifted into robotics, and my training is in perception for manipulation. I've been at Open Robotics for 4 years. I mainly do simulation these days. In the last 2 years, underwater and maritime simulation. And yeah, I'm happy to be here and looking forward to a lively discussion.
Awesome. And of course, we have Adam Dąbrowski, who is the VP of Simulation and Robotics over at Robotec.ai. Adam.
Thank you, Royal, and hello, everyone. My background is in computer science, and I like robotics and software around robotics the most. So that's my area of focus since quite some time. I've been busy with simulations. I also work as an independent expert evaluator for the European Commission to determine which projects in robotics are worth the funding. So I will be happy to discuss open source robotics in the panel.
Awesome. Awesome. Thank you so much. So hopefully this gives everybody kind of a general idea of who the panelists are. If you're wondering how I became the moderator and things like this, my background, I've been in the games industry for over 20 years. I've been an engineer for over 35 years, working in quite a few different areas of software, C++, game development, tools, utility chains, patents, all those fun things. And so it's great to be able to have and be surrounded by so many different individuals here that have such a great diversity of background to be able to give their opinions on some of the things we're doing in robotics with open source and open 3D and what the future might look like. And so, looking at things from the future, there are a lot of current trends and things that are happening. And so, if we think about what's happening, what's evolving, what's changing within the landscape of robotics, there are a lot of challenges that are coming around. But I think the one thing that we can all clearly state is that there is an explosion of different simulators that have happened in the recent years, and where we're seeing different renderers, different models, different source code, open source, closed, and everybody's trying to kind of become this holy grail of the one-stop shop in simulators. And so I want to start the panel off with that question, with what exists today. I mean, why is this such an important search for a one-stop shop solution? I mean, is this actually realistic? I'll open this up to Adam. What do you think?
All right, that's quite an interesting topic. I have my opinion here. So we have quite a variety of simulators, as Royal mentioned. We have traditional simulator, which has a large community and a huge importance in robotic community, which is Gazebo, both Ignition and Fortress. Since I think it's important to preface that with the fact that ROS, the robot operating system, is the most important standard in robotics. So when we're talking about the simulation for robotics, the integration with ROS is paramount. Then we have simulators which are based on game engines. The reason for using game engine is that they provide a lot of assets, free value, performance, and so on. That's quite similar between games and robotic simulation. So the value is there to use. And we have a variety of approaches for licensing as well. But I think the most interesting ones to discuss today when we focus on open source are the ones that are open source. And here I would like to perhaps introduce some of our viewers to Open 3D Engine, which might not be known to everyone, but it's a very promising new open source simulator.
Awesome. We've talked about the kind of one-stop shop thing in open source, but I'm a little bit interested. I mean, we've got both Matt and Lars, these larger organizations, and I'm interested about the superscaling of this one-stop shop theory. Matt, Lars, what are your thoughts, with scaling a one shop? Is that realistic?
No, sorry. So I don't think that one-stop shop is going to happen anytime soon. Maybe someday in the distant future, the vision of having a unified metaverse will exist, and there will be some all-encompassing simulator that can simulate everything in known to mankind. But I think we're still at least one generation of simulator away from that, possibly more. But I do think scaling is a huge issue today, and that's what I work mostly in that area, is in helping companies that are doing simulations take their simulations from running it on like a local desktop machine to, scaling that out to running it in the cloud, running, tens of thousands of simulations a day in order to, do large volume data collection, validate their software, and prove that their robot is safe and meets the necessary requirements.
What do you think, Lars?
So what I feel like we're seeing at the moment is an explosion of simulators. So we have a lot of new simulators, especially around and integrated into game engines, being developed in or popping up in the last months and years. But probably a lot of them will stay small prototypes or applicable to specific areas. So depending on what kind of robotics application, whether it's drones, service robots, marine robots, depending on what kind of use case you're trying to target, you have very different requirements in terms of feature sets and in terms also of trade-offs for the implementation. And what we are seeing with engines like O3DE and other game engines with robotics integrations is that they can really benefit from an ecosystem. So a big difference here is that the game ecosystem has developed over years, and there are a lot of ready-made tools available to integrate with virtual reality headsets, to integrate with asset stores, to integrate with the best tools in 3D world creation and so on. And that is one of the strengths that O3DE is also bringing for me moving forward. It's an open ecosystem that a lot of major players are contributing to. And you can ask why O3DE? There are other game engines, but it's the only really open game engine out there. And it's the only fully open source royalty-free solution that exists at this time. Of course, there are other game engines, right? But I see O3DE becoming more important in the next years, and not becoming maybe the one-stop shop anytime soon, but bringing us closer in that direction, growing in ecosystem together with the open source game ecosystem.
Right. Yeah. It's interesting because you're looking at this from the open source perspective and the ecosystem, and I know Mabel and Robin, you've had a history also in open source, obviously with open robotics, and in different areas. And I'm kind of curious, like when you see what they've talked about in their examples, kind of your perspective of how you've seen the evolution of open source and robotics and these engines kind of play in that ecosystem. What are your opinions on that with the whole trend and the idea of the one-stop shop in open source? There's a lot to unpack there, but I'd really like to hear your thoughts on this.
Can I go first?
Sure.
So I would put two perspectives in there. First is the technical perspective. I don't think it's possible to have a one-stop shop because there is an inherent trade-off between physics and rendering. Unless you have a infinitely powerful computer, you just cannot get infinitesimal small numbers. And we see that a lot with like maritime simulations. How do you simulate the dynamics of waves, of water? We don't even know how to simulate that. And then if you trade that off with rendering also requires really, really quick time steps. And that is why the rendering of game engines is so powerful. And when people see that, they immediately say, this is the best simulator for me. I don't need other things. Whereas they don't see the physics. And the physics is what Gazebo decided to prioritize versus rendering. So that's a technical perspective. And then from the organizational perspective, specifically, Open Robotics has been working with NVIDIA, TRI, DeepMind in the past few years to create converters between the formats of all these simulators. And that kind of tells you nobody's really aiming to be the one-stop shop, since we're trying to convert between, okay, the say TRI Drake format and Gazebo format so that we can load files built for another simulator, like the game community for Omniverse into Gazebo and vice versa, so that we can take advantage of each simulator for whatever application they happen to be doing.
Awesome. What do you think, Robin?
And I think it's a tough question. We didn't ask the question of, well, should we even have a one-stop shop? that I think could take up the entire presentation, so I won't go there. The thing that I think about is I've worked with the hospital metaverse, precision farming, utilities inspection, gaming, retail, major motion pictures, ground and transportation systems, and is Linux a one-stop shop? I mean, that's kind of what we're talking about here, because at some point the metaverse becomes the operating system, and so yeah, I guess so. But I lead an open source project that is called Cinepaint, and we've been talking for a long time about adding game engine features to it. I think we will pretty soon, but it's not to compete with O3DE. We're not trying to become the biggest game engine in the world. We're just trying to make it easier for artists that maybe want to work on game elements to be able to do some simple things so they can see what they're doing. So I think it's both. I think that we're going to have these big tools, these very rich tools, and maybe big is the wrong word, like O3DE that try to be as much as they can to everyone. And then we're going to have specialty tools that are just could be potentially a very small subset of those features, but are designed to help people with something that's much more specific.
Right.
And I think it comes out of the tools that people already use as well. If you're working as an artist at a film studio, you have tools that you're used to, and say, okay, well, next week we're switching to O3DE. That might be a little steep.
Right. And it's funny. I kind of interject something from the summary of what I was talking about. I had this conversation the other day where we were talking about somebody was talking about a kernel driver, and they were going, well, is the kernel driver the core of the operating system? Which was an argument. It was a really interesting conversation that we had about that, because it goes into what is the core? What is the one-stop shop? What does that really tie down to be? And it was, well, the answer is yes and no, because depending on the application, like I can build a Linux core that gives you a complete desktop, or I can give you a completely stripped down Linux core that runs an IoT device. Which one was core? Which one was my one-stop shop? So it's also a loaded question, I think, at the same time when you ask that, because you'll never just have one place for everything. There'll always be something that extends on top of it that makes it into its complete package of what it is. And O3DE being one of the tools in the arsenal to be able to bring robotics to life using other systems like Gazebo or using other elements. It's the interoperability of being able to do that and using the right tool for the job. So, that kind of, and the nice part is we have a lot of history to draw against that with Linux and open source and different places like that, because companies have used them forever. But there are also kind of different trends and challenges. So I want to open that up to everybody here. What do you like? We see the changes that have happened in the past year and a half, 2 years with Ogre, Gazebo, Robotics, Ross. What are some of the other challenges that you see in the robotics industry, some of these trends? It's open for anybody. Don't be shy.
I'll start off, but it's maybe not answering the question you meant to ask. The biggest challenge in robotics is always the hardware. That we're always limited by what is available to build in the physical world. And having good simulation is one way that we address that, is to say, well, what can we actually build? Because I don't have polymuscles or whatever it is that I wish I had that would be better than gears and motors. Hardware is what makes robotics hard.
Everybody agree with that?
Well, so I agree to some extent with that, in that, but I do think that simulation is how you can enable yourself as a robot developer to make progress without being constrained completely by the hardware, right? Now, in modern robotics software development workflows, you're going to test 1,000 times in simulation before you test on the physical hardware, and that's probably good because a hardware development team or person, whoever's doing that, it needs the hardware in their hands most of the time. They in order to verify that all the mechanical and electrical is working. So you don't want two teams, your software team and your hardware team, both being bottlenecked by a limited number of prototype hardware systems that you have. Simulation enables you to basically break that bottleneck, decouple the software from the hardware much better.
I fully agree that this is a very important change happening. I personally see like two big drivers also for simulation and robotics. The first one is exactly DevOps coming to robotics in more areas. So you're no longer physically constrained to the hardware, just like Matt said, but you can develop and iterate on your software stack for your robot and test it in simulation. And this actually also works for each individual simulated robot at super real time. And you can, of course, run as many simulations in parallel as you have robots. So this really opens up new avenues for testing. And it also makes it possible to test scenarios which may not be safe in the real world, right? And this connects to the second big trend that is currently really happening in academia and slowly moving also to industry, which is AI and robotics. And here we have, so with AI, we always have this problem that training AI models is very sample inefficient, or at least today. And if you would want to train a neural network, let's say, on a physical robot based on the data that it can collect in real time, you would have to wait a few years until it learned anything useful. But if you run it in simulators optimized for this, which can run at hundreds, maybe thousands of time real time, you can really learn helpful behavior much quicker. And with learned models, you always have this challenge. It may be unsafe. And so you can also actually generate a lot of scenarios in simulation where you can test corner case behavior of your control stack. This also applies for traditional control stacks, of course. And we see a lot of applications for that already, for example, in autonomous driving.
So I might add, I fully agree with Lars. I will add that I still see a lot of companies that do not appreciate the value of simulation for building robotic use cases. This is still happening. So I think one of the challenges for advancement of robotics is actually knowing the best practices and understanding and also the knowledge in the public about which tool is good for what are the best modern practices for simulation. Depending on your approach, of course, because we have different goals for simulation. So it can be used to quickly prototype a solution. It could be used to validate, to have CI regression testing, integration testing, and so on. We can use it for synthetic data generation, so for machine learning to enrich, to make our data sets bigger and performance of our machine learning detectors better. And then, which is very important, we can also use it to visualize the use case for customer, which very much helps to convince people, okay, that's how it will look like when I deploy the robots in your place, and this is the productivity that you can expect, and so on. And you can work with this in a kind of relationship between the real case and the simulation. So there are many angles to approach when you try to answer the question, what kind of simulation should I use? What kind of effort should I put into the simulation? So it's what do you want to take from the simulation? So these four approaches, right, are important. Then, of course, what kind of use case do I have outdoors? Do I have underwater use case? And then, the physics engine would probably be determined by that that suits you. And then again, you might opt to choose two simulators. So one that is highly performant, looks pretty, has good sensor simulation, nice ROS integration. And the other one, which is perhaps focused on great physics for this specific thing that your robot does. If it's aerodynamics, if it's movement on the racked terrain, you can test that separately in the other simulation. So I think the knowledge of that, what are the best practices, what are the tools that I can use, is something that is still lacking. It's a challenge.
One of the things, and to make this easy, we'll kind of give me, or each one of you give me like 3 or 4 points you think, real short and sweet, of what you look at when you're trying to pick a simulator. What are the considerations? Just give me 3 or 4 points that you think off the top of your head.
I'll start.
Okay.
Can I start? Because I didn't answer the previous one. I'm kind of going to spin off the previous one.
Cool.
Put a positive spin on it. We do see that in the last few years, organizations are increasingly trusting open source simulators, and we can see that from our work with NASA Viper. They put a ROS on the ground software to send something to the moon. That's mission critical, and simulation is really important to NASA because they only get one try in the real world. And then we see that in autonomous driving. We've been working with Apex AI, and they stripped down ROS2 and got it certified. And that's one example of seeing how people are actually trusting ROS2 on the road. And then in marine robotics, they really have a need for simulation because it's similar to space. The cost is really high. So I would say in order to pick a simulation for industrial application, to answer Royal's question, one point is that it needs to be something that's, some part of it has to be guaranteed, like certifiable, needs to be able to validate it. A second thing I would want is something that can be modular. I can add something to it, strip down the things I don't want. If I want to put it on an embedded system, I don't want to have like 3 gigabytes of stuff. A third thing, if I'm an educator, I want a simulator that's going to lower the education barrier for my students to use. So if it's cheap, if it's free, that's the best. I'll just leave 3 points there.
Anybody have extra points to add to that?
I think that if you want to pick the best simulator for your use case, you should look at the features that you actually need to simulate. So I think we've touched on this topic a few times already in the discussion, but really the kind of different simulators focus on very different aspects of physics, of simulation, depending on what kind, for example, of interaction between the robot and environment you have. Like, for example, do you have a gripper, right? Do you want to grip deformable objects? Then if you want to train a machine learning model that is capable of grasping objects in the real world, you actually need to have a very good simulation of these deformable physics in the simulator. And the majority of our simulators we have today does not support simulating these soft body or even deformable objects well at all. So it really depends on the kind of application. Like for, let's say, drones, right? You want to develop a drone and you want to validate the aerodynamic properties of that. Probably none of the open source robotics simulators will offer you that kind of simulation right now. So really look at what kind of scenario do I want to simulate, then which of the simulators has the best tool. And coming back to this question of the one-stop shop, I think what we will see in the future, what we don't have yet, but which several vendors are working towards, and I also see that as a route for O3D, is to have the modularity on configurability to select exactly what you need. Right? So then in the end, you have profiles for templates, profiles, configuration options for each application scenario, where you can enable and disable different aspects of the simulator for your use case. And even within a single one, right? Let's say you're trying to train a locomotion controller for a legged robot. It's actually not a good idea if you're doing plane reinforcement learning to start with the accurate simulation, because you will spend a lot of budget on simulating physics that don't give any. It would actually be sufficient to learn the basics to do a very abstracted, very approximate simulation of reality. So it always depends on your use case. There are a lot of and also on the stage of, or the method that you're using and what you're trying to validate, what's the best tool for the job.
Right.
Mm.
And that's, I think modularity is definitely part of the key, of being able to do that, where at least you can have different subsystems that you can plug in together in a known framework that you can operate. And so, I actually want to spin in the direction that Mabel started going into, which was, we talked about kind of what the landscape of robotics looks like, but, how has open source actually impacted that world of robotics? And, what's your thought on the direction of, what it's doing? And Mabel, I'd like to have you actually open up on this one.
Sure, yeah. I think a really baseline point that everybody can agree on is that before ROS, everybody was writing up their homebrew version of interface to talk between the robot, the hardware, and then hardware, middleware, and then finally get to software. Okay, now I can implement my computer vision algorithm. So ROS really opened up the world to not having to build all the nitty-gritty, dirty stuff and actually focus on your solution. I would also like to point out that while everybody thinks that open source is free, it's free to the users, but it's not free to the maintainers. And if you look at all of the open source projects, you just Google open source maintainer complaints or anything like that, you'll see that there's a lot of work involved, and people should really appreciate how much effort it is for maintainers to actually fix bugs, maintain, and add features, and how much the server costs are. And all of the maintainers will say that there is a challenge in people from companies maintain it, and then people drop off, and we don't have enough community to do all of the things that open source project needs to do. So that's something that people should really be aware of.
Yeah, I'm a little curious, Matt, what's your perspective like with what you've seen that open source and impacts? I mean, obviously AWS Robotics, like you have a ridiculous amount of robotics that operates. And so what has open source been kind of from your perspective?
Yeah, well, I agree with what Mabel was saying, and I'm a huge proponent of ROS and ROS 2 myself. So I agree with her that ROS and ROS 2 have definitely improved the lives of roboticists over the last decade. I think we're also seeing this with the simulators as well, right? Gazebo is open source, Open3DE is open source, but the maintenance of those is a high effort, and so it's a dual-edged sword there, so to speak, right? It's there's a trade-off between having something that's completely open and free, but then you do have to pay a cost at some point. So companies that want to use it should be contributing back, for example, to Open3DE or Gazebo, fix a bug, add a feature, contribute back upstream. I think it's great for the overall community, but the word community is important. You need to have a community built around it where people are actually contributing, and it's not just a small set of maintainers doing all the heavy lifting.
Yeah, and Adam, you're really active in that area. I've seen a lot of your work, so I'm interested in from your view.
So of course, ideologically, I like open source. It's very motivating to work on, to know that you have this kind of social impact, that people are using your solution, that someone is benefiting. So I think that's not just me, that's many software developers. You get a team that's more motivated to work on that actually. And there is a nice feedback loop for between more experienced maintainers and newcomers. It's mentorship. I think that more and more companies are embracing open source. It's a visible trend, and it's happening often due to the nature of the project, that we have large open source projects where you get a lot of value. You are interested in going into a certain direction, but you want all the tooling to also be improved, which you don't necessarily have to do yourself as a company. So you get a lot of free value, and there are open source models for smaller companies as well, based on cooperation. So we do have models such as open core model, where you present, let's say, a fully functional open source library, and then add some features that are very specific to your customers, which are closed. Then you have a software as a service model, you have support and services model, so we can discuss that. But there is a growing awareness, I think, so the role of the open source in the overall software development that is happening worldwide is increasing.
Yeah, I mean, so Lars, Robin, what are your thoughts on just, open source and the impact into robotics and some of the direction of it?
I mean, we touched upon Linux before, right? So without Linux, we wouldn't be in the world where we are now. So it runs on on a majority of the cell phones in the world. It runs now on many newer industrial controllers. It runs on microcontrollers, on security cameras, on servers, in Amazon cloud, in Huawei cloud, in all the clouds. Basically, all the workloads, all the big workloads are running on open source, and the same will probably happen at some point for 3D, right? Currently, we are seeing very clear technology leadership with commercial companies, but they also, to some degree, are working with an open source model, right? It is not royalty free, but it is also open source, because you have so complicated technology systems that now, as a developer, if you want to use such an engine, you want to tailor it, or such a project, and want to tailor it to your needs, you cannot redevelop it from scratch. It's just too much of an investment. You can tailor it to your needs, and then there's a question: what's the business model for that? Open source will, from my perspective, definitely rule the software world in the future. About the licensing models and which products will win, I'm not 100% certain, but robotics is such an open community now. There are so many challenges to solve. It's probably one of the most complicated, complex engineering challenges that exists today. And as an individual company, or even an individual contributor, you cannot solve everything at once. So we really need to, from, again, an ideological perspective, we need to come together and work together and solve this global problem of our time more or less together. And we need to find models how each company can find, just like Adam just explained, find their core feature that they can commercialize and earn money with, because let's face it, open source development needs to be funded as well somehow. But work closer together in open source projects to speed up the development.
It's an interesting point that you brought up, that some people look at open source where it's this free thing they can attach into, but you're right, it does have to be funded by the different organizations. And the interesting part of it is that when you look at the funding, you're either going to have to maintain an entire architecture or system that you've built, which means having dedicated full-time engineers who are maintaining that software, updating it, keeping it running, current, adding features to it, or you're supporting a project that has other organizations. I think the big difference with open source, and especially with standards, and when you were talking about ROS and ROS2, is that it gives all of the companies the ability to speak in the same language for that limited scope of what you're trying to accomplish, even though it's not your exact business goals. Each of you may have different objectives, but having that common language to build from is what prevents you from basically all writing the same thing at the same time and expending all of that extra energy and money in a direction that's not necessary, when it can be, it's kind of table stakes, I guess, at that point, is a way to look at it. And so I think standardization with ROS and ROS2, that's probably the biggest impact that Mabel brought up, was that everybody was writing their own thing and it was a wild west. So how in the world do you ever get a chance to amplify off of each other's work for something you're not even making money off of? You're basically trying to build the systems to get to the piece that will make you money. Does that make sense?
Yeah.
Yeah,
Can I comment on this? Sorry.
Yeah.
So you mentioned Wild West. I think it still is a little bit of the Wild West in the simulation space. I think ROS and ROS 2 have made it less so in the robotics middleware space, although it's still there's still quite a few people that are doing their own custom stacks. But obviously ROS and ROS 2 have gained a large segment of the overall, probably the largest segment of the overall robotics community. I think with simulators, it's still pretty Wild West. I think a lot of companies that I talk to are actually writing their own custom simulators in-house still, and because they think they need to. They don't realize maybe what the options available to them are. And I think that things like O3DE can save them a lot of work. I think hopefully we're coming to a similar kind of a point with simulators now as we were with ROS and ROS 2 5-7 years ago, when it kind of started really ballooning and taking off. So, but yeah, it remains to be seen. But I think we're like on that precipice now. So
yeah, it's interesting you brought that up. Having tools like O3D, because you look at some of the trends and challenges and things that are robotics, and people are making different considerations as to what's it going to cost them, both in time, fiscally, manpower. All of these come into play. So I'd like to open it up to the panel and just talk a little bit about Open3D Engine, which we've kind of tossed around here and there, and how it fits into that landscape. And so I guess my first question is,
Royal, before you move on from the prior topic, I just want to touch base because you mentioned standards, and we haven't talked about how much work people put in doing those standards. This isn't just code maintainers. I'm on ISO and ITU standards committees, and it's a tremendous amount of work. I'm preparing to fly to Geneva. I'm voting on standards, and my company is paying this. No one is paying me to do this work. I just became chairman of the ITU Metaverse Trustworthiness Committee. We're trying to figure out how you define trust in the metaverse. So it's not only the maintainers, which I have a lot of experience with that because I maintain open source code as well. It's also the people that do all the work on standards, which I think includes you with the Linux Foundation and places like that.
Yeah, it is important people to understand that it's not free, it's still people's time. And that it really does come down to community and people who contribute their time, willing and wanting to do this, not just from, hey, I'm going to make $1. I think that is a big point.
Yeah, and everybody likes standards, but it's pretty unappreciated work to actually work on them and get them to make them be standard.
You mean there's no trophies? Come on, man.
I respect you, Robin. Thank you for the work you're doing to create standards. We need that.
Absolutely. With standards, there's also always this question: what comes first? Is it first you have the solution and then you standardize it, or do you try to develop the standard and then implement it? And correct me if I'm wrong, but for example, with ROS, I don't think that it was originally developed with the intention to become the standard middleware for robotics, right? Like it basically came out of a need to modularize development and be able to share packages, and then became hugely successful because you have suddenly building blocks that you can reuse and quickly build things that actually do something meaningful, right? You do not need to start developing your own driver for every sensor that you use and every actuator, but you can actually just with Linux, you install the operating system, the middleware, and you actually start working on the problem you're trying to solve. And I think for simulation, this is exactly where we need to go, right? We want to build a modular ecosystem where you have templates and open source packages that you can just integrate and reuse and build upon. And building this ecosystem, this community for simulation is, I think, something that's closely related to the metaverse, to the efforts in that direction. But yeah, like Matt was saying, I think we're probably not there yet. So it remains to be seen how exactly we solve that.
So then I guess that poses the question, why another simulator? You know, what's so unique about O3DE and its community? You know, how does it address what we've been talking about?
So if I may, I would add to the list of the points of what we are looking for in a simulator a couple of things that might be a good introduction to O3DE. What are the strengths of O3DE as well? So from my perspective, performance is quite important for simulations. If you want to simulate large areas or lots of robots or sensors that produce a lot of data, then it's really important for you to be able to run the simulation sensibly fast, especially if you care about real-time simulation, which is useful for many reasons. Of course, the standards, so adherence to standards, so the interfaces that the simulator provides, how well it's integrated with ROS. We, of course, do not have simulation interface standards yet. That's something to produce, I hopefully in the near future. And then another point is, of course, what technology is used, what programming language is used. Do I have to hire a special team, or can I use ROS developers to also develop, the simulator itself or the modules? So I do prefer C++ and Python interfaces, right? Programming interfaces, code base. And then coming to the very important point, the documentation, actually. So I do care about the simulator being well documented, so that I can find solutions to my issues. I can find solutions to my challenges. And O3DE here, I think, is representing quite a modern approach with a lot of awareness of these requirements. And I think that we have a very attractive renderer here, so Atom. We have modular architecture, which is extendable. These modules are called gems. We have what I consider the best kind of ROS integration. So forgoing abstraction and deciding that we go all in on ROS, in a sense that we write ROS to code in the simulator, actually. So we can use all the packages. We can integrate directly without any bridges. And again, this impacts performance, because then we can also communicate directly to ROS ecosystem. We can even record data using ROSback API, so also efficiently. And then we have the goals that we have for the simulation, which I think O3DE is quite suitable for. And I can say that, for example, to present your use case to the customer, we actually did that with O3DE, and we have a customer project with O3DE right now. So I can speak from experience. It was very good to prototype robotic simulation quickly with O3DE and ROS2, and we were even surprised how little effort it took to produce something beautiful and telling a story.
How long did it take you to kind of ramp up and build something on it? Just curiosity.
1 week. So that was 1 week to actually, so 1 person week, I would say. Of course, we are quite experienced doing that, but I think for what came out, it's pretty impressive. So we were also impressed.
Interesting. Lars,
Yes,
Matt, anyone? Yeah.
So that being said, I think Adam made a very convincing case from the developer perspective or technological perspective for O3DE. Of course, that's not the only perspective, right? So documentation, I think, is always something that can be better, and onboarding experience with O3DE is also something that's consistently improving, but that can be easier. So a lot of, I think, customers that would come to O3DE, or new companies, new potential contributors coming to O3DE for the first time, there's a lot of concepts to understand and a lot of pieces to set up to get moving still. I think where we want to go at some point is that you can use an ecosystem of tools. So O3DE will only be one tool within that. But for example, if you have a warehouse or some production site or some outdoor environment, whatever that you want to get started with, you use the best tool to create a digital twin of that environment, quickly import that into the engine. You don't have to worry about how to set it up properly in terms of all the artist workflows, textures, lighting, and so on. But all of this should be fast and easy with good defaults to get started, so that you can directly focus on developing the piece that you need for your customer case, right? That can be simulating the industrial use case that you're looking at. That can also be implementing the sensor that you're trying to simulate in the solution. But streamlining the ecosystem and the time that you need until you actually get started working on your specific problem, that is a key challenge for not only O3DE but for the entire open source ecosystem in terms of simulators right now. Also for commercial simulators, but a lot of them are more targeted at specific use cases. So yeah.
Interesting. I think, yeah, modularity is definitely a key piece. Like, you don't need a first-person shooter to be the basis of what you're doing. You want to be able to remove everything out and build up, because unbuilding and unwinding is just as, if not more painful than building in many cases. So, I mean, Matt, do you have some thoughts on what we're talking about?
Well, I think modularity is definitely key, and I agree with that. But I think scalability is the next big thing. The ability, so everyone thinks of, oh, well, you can just add more compute to a single simulation, and you can do more within that simulation, right? I mean, that one's kind of the obvious way of increasing your performance of your simulator. But I think the ability to scale out horizontally as well is like the next big wave that needs to happen, and the ability to basically spatially distribute simulations. Say you want to simulate the surface of the moon and have many different robots. You want to simulate robots building a human settlement on the moon. That takes spatially dividing that across many simulators, having many robots working in a swarm together to collaborate, cooperate. You may be running some reinforcement learning algorithms on some of them. All of that requires computing and scaling your compute horizontally. And I think that's something that I'm really excited about happening in this next generation, next 10-ish years, I'll say, of simulation.
Yeah, I definitely can see that. I think having, when you're talking about simulators and engines, having them Linux-based so that they can scale out in the cloud very quickly, that they can use some of the new advanced GPU features, that they can actually do these things. Because like what Adam, and had brought up before, which was, you're only going to get so many devices that you can operate. And, I think, Lars, you talked about this too. You need simulation to create those hundreds of thousands of hours to be able to get that simulation. And so I think having cores like that are really important. I'd like to get Mabel's take on, what she's seen with O3D and some of the impacts that she's seen with open robotics and these kind of engines as well. What do you think, Mabel?
Sorry, could you repeat it? I was looking at the Q&A.
That's right. So, I mean, we're looking at the role of what O3D plays in some of these challenges, and what you've seen and what you've observed for what it could do and what it can do for the robotics industry as a whole as an engine.
So I personally have not used O3DE a lot. I think the ROS integration is definitely going to get a lot of users interested, as that's what we've seen with simulators. I think one cons that I've seen from O3DE, at least from my own limited resource laptop, is that O3DE does have a more modern requirement on GPU for rendering, which I feel like that's something that could be addressed so that people, you mentioned turning off the rendering engine. If people want to do that, maybe there's a way around it. Yeah, I don't know. I have a lot of views on yet another simulator, because we do see a lot of these. So I don't know if I'm the best person to answer that.
That's okay. Well, I guess the piece here really comes down to, how do we see the robotics industry working with 3D engines, to kind of tackle some of these forward challenges in the future, and that's kind of open to anybody. Anybody have any thoughts on that?
So of course we would love to see more adoption and contributors and users. There is always a certain anxiety when trying to use a new complex tool and software tools like simulation engines could be quite intimidating, because they are quite large by nature, right? When you want to simulate everything, this is going to be a big project. So I just encourage people to give it a try. It's good to have knowledge of important exceptional tools in terms of how quickly they are being improved, the modern solutions that they use, and so on, to stay in the game, so to say, to be sure that we are using the most modern solutions available.
Right.
Can I get one last positive spin on that? I think a great thing to focus on is, since you started with a game community, it's important to use the game ecosystem, because it's quite large. There's a lot of assets available from game engines that people might be able to use readily. And the other similar community to focus on is the vision community, because these people are really the people with the big GPUs, and they really care about the appearances.
Yeah, that's true. The funny thing is, you can go to Sketchfab, type in CC0, and pull in, I think, over 800,000 different objects right into O3D. I literally was doing that. There's another thing called, I think, Objaverse, where they've indexed them all, and you can pull down the GLTF files and import them right in and start using them as is. So it's very interesting being able to have the games community and the game engine with all these 3D assets that are readily available that you can actually go in and build from. And so we only have a few minutes left, and so I want to get kind of we got 3 minutes, and as we wrap up, I want to talk about what's one thing that you're looking for. So kind of sweet and concise. Robin, what's one thing that you're kind of excited, looking forward to, that you'd be excited about?
Well, I think everyone today is talking about generative AI and replacing programmers with AI. So there's a lot happening in the AI realm. And at the same time, I look across the spectrum politically. I've run for political office, and I look at the huge gulf between what I understand about systems, the technology realm that we're entering into, and what the average person understands, which in many cases is absolutely nothing. And so the question becomes, how do we cope with this as a society? And I don't have a good answer for it, but as I watch stuff come across the news, and look about the particularly in America, we're seeing a clash of cultures where we have a political party that is anti-science, and that doesn't work so much in a scientific culture. I mean, we're all very dependent on science. We don't really have the luxury of being anti-science, even if you wish to be. So
Well, actually, I want to
you know,
put this in.
this device, you know, that just
Yeah.
interrupted our session. You know, science can break in on us at any inopportune moment.
Yeah.
And how we, you know, deal with the people that you know wish to have the benefits of science without the responsibility of it. I have no idea.
I think, yeah, and to keep this kind of in context, it was actually kind of the innovation in robotics, you know, and the robotic simulations. Like, what's the one thing you're looking forward to? And I guess, Lars, I'd ask you that question.
So for me, it's closely related to that generative AI because it's about simulation technology becoming much more accessible. So for a lot of users, something that makes it hard to get started is basically, you know, getting their environment set up properly. And with AI generative tools moving more and more into the 3D space, and, you know, animations becoming easier, model generation becoming easier, scene layouting, procedural scene generation, and so on, moving more into the mainstream space. I think these things will all make it much easier in the short future to get started with simulation and robotics.
Right. 30-second clip. Mabel, what do you think? What's exciting for your future?
I'm going to base this on my recency bias of working on marine robotics. I really want to see simulators help us solve some of our environmental problems. I'll stop there.
Matt?
Yeah, these are all good. Yeah, I think, you know, the metaverse, the ability to really simulate everything. I think more and more things are going to move to simulate first. I'll just say, and that's over time. I think by the end of this century, you know, simulation will be like everything will be able to be simulated. So,
Adam?
pretty exciting.
Personally, I would love a kind of competition project around space robotics, where, you know, there's a lot of team to participate, and they are using Open3D engine to compete for certain tasks. I would love to participate in that.
That would be pretty awesome. I think, you know, I think going to kind of a mix of all the statements, and especially teeing off of Matt's, which is everything will be simulated at some point in time. And I think the reality is that we're looking at this future of where digital and physical are going to start kind of converging, and simulation is going to be the key, that it will keep you in immersion. And so I think a lot of people don't look at robotics as important as it truly is, and how that will tie in with AI and generative and the things that they want to see in the future. So, you know, all of the elements that we've talked about here actually do have a play. And it's interesting because things that are not in the robotics industry have such an influence in the robotics industry, and vice versa. And that really is. So if you're not from this industry, you should still find it interesting, because you'll come to find out that eventually you may get pulled in one way or another. So, so with that, Nicole, I'll kind of hand it back to you.
Thanks, Royal. I want to thank all of our amazing panelists for being here today, to responding to questions, sharing your thoughts, your insights, and to all of you out there for joining us. This is really just the beginning, so look for us to have more discussions about you know, open source and O3DE in robotics, and diving into different aspects. We'd love for you to respond to the survey to tell us what you'd like to hear about, right? And what we can do better. The recording of this panel discussion will be available in O3DE YouTube. It will also be mailed to you. And we'd also like you to, or invite you to chime in for next month's discussion, where we will be talking about how we are collaborating to advance game development across AR, VR, and XR interfaces. So stay tuned for that one. And again, thank you, everybody. It's been great.
Thanks, everyone. We really appreciate it. Fantastic having all of you.
Great. Bye-bye.
Thank you.
Thank you.
Thank you.